Application of logic in real life, MAT 210. So for our group member, we have Amira Aimi binti Latpi and Tuan Nur Aisyah Damia binti Tuan Hassan.
Introduction. Logic in discrete mathematics uses connectives like AND, OR, NOT, and implies to form expressions. Truth tables determine their truth values. Statements can be tautologies, always true, contradictions, always false, or contingencies, true or false. Logical implications show relationships between statements, and rules of inference help deduce new conclusions. These concepts are essential for problem solving in computer science, philosophy, and mathematics itself. Moving on to statements. A statement in logic is a sentence that asserts or denies something capable of being true or false. It typically consists of a subject and a predicate expressing facts or beliefs that can be analyzed using logical connectives to form complex expressions. For example, we have a verse of "The sun rises in the east," which is a statement with a truth value of true. Next, we have 2 plus 2 equals to 6, which is also a statement, but the truth value is false. And then we have a dialogue of saying, "Tell about the galaxy," which is not a statement, thus is not have a truth value. And then we have 10 is a prime number, which is a statement, but the truth value is false. And lastly, we have the last verse, which is, "If it is Sunday, then tomorrow is Monday," which is a statement and truth value is true.
Logical connective. What is logical connective? The meaning of a logical connective is a word usually written as a symbol that carries a particular instruction of a logic on how to operate statement or compound statement. Logical operator can also be used to join or combine two or more statements to form a new statement. The true value of a statement will completely be determined by the true value of its primary statement. Several logical operators that is being used are conjunction, disconjunction, negation, implication, and biconditional. For a conjunction, the statement is AND, and the symbol is like a V but upside down. For this conjunction, the statement is OR, and the symbol is like a V. For a negation, the statement is NOT, and the symbol is like a wave. For implication, the statement is if, then. The symbol is like an arrow, just one arrow. For biconditional, the statement is if and only if. For the symbol is like an arrow but with a two arrow. Truth table. A truth table is a mathematical table used in logic which set out the true value of the logical expression on their functional arguments. The truth table can be used to show whether a proposition is true for all legitimate input value, logically equivalent, or logically implies. For a conjunction, the meaning in truth table is true if the statement P and Q are both true. Otherwise, P conjunction Q is false. For a disconjunction, is also true if both P and Q are either P or Q is true. Therefore, it is only false if both P and Q are false. Negation. Value of a negate statement is exact opposite of the true value of the original statement. Next, for implication, P implies Q. If P then Q, it is false if P is true and Q is false. Otherwise, the other statement P implies Q is true. For a P biconditional Q, true when P and Q are same, either both are false or both are true. Tautology, contradiction, and contingency. What is tautology? Tautology is if all truth value are true. Contradiction. Contradiction is if all truth values are false. For a contingency, if the truth values contain both true and false.
Arguments. An argument is when you use one or more statements called premises to support another statement called the conclusion. The premises act like evidence or reasons to show why the conclusion is true, similar to testing a hypothesis with supporting ideas. For example, we have P implies Q and P, which we will be applying the rules of inference and get the answer Q. As you can see here, we have the truth table of P implies Q and P implies to Q, where the truth value of P is true, true, false, false. For Q, true, false, and then P implies Q, true, false, true, true. For P implies Q and P is true, false, 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 and lastly, the result will be true, 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 which is a tautology. In conclusion, since P implies Q and P implies to Q is a tautology, therefore the argument is valid. Next is logical implication. A valid argument is when its conclusion is true whenever all of its premises are true. One way to show an argument is valid by demonstrate that the statement is tautology. Tautology is a propositional statement is true in every situation. For example, if the statement A implies B is tautology, then we say A logically implies B. For the example of logical implication, Amira will play badminton. If it is raining, then the ground is wet. Therefore, Amira does not play badminton. The solutions for this is that we assume that P is Amira play badminton, Q as it is raining, and R the ground is wet. First sentence, we conclude it as premise 1, which is P, premise 2, Q implies R, and the last sentence is the conclusion, which is not P. And on the left, we can see the truth table for Q implies R implies not P. The truth value for P is true, 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 false, 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 false. Q, true, true, false, false, true, true, false, false. And then R, true, false, true, false, true, false, true, false. After that, Q implies R, true, false, true, 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 false, true, true, and not P is false, 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 true, 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 and lastly we will have our result, which is false, true, false, false, true, 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 which is a contingency. In conclusion, since Q implies R implies not P is not a tautology, therefore the argument is invalid. Moving on to rules of inference, the validity of arguments can be tested by using the rules of inference. The rules of inference, also known as inference rule, are a form of argument to draw a conclusion. The list of rules of inference are based on the table below. In the table, we have the formula for modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunction, and resolution. For the rules of inference example, we have if Atan have enough saving, then he buys a car. He is frugal or he has enough saving. He is not frugal. For the P, Q, and R, we conclude that P is Atan has enough savings, Q, he buys a car, and R, he is frugal. For the premises, premise 1, P implies Q, premise 2, R or P, and lastly premise 3, not R. And on the right, we have the premises arranged from 1 to 3, which is P implies Q, R or P, and not R. And the next step we have to do is take premise 2 and 3 and do syllogism disjunctive, which will be resulting in P. The fifth step we have to do is do a modus ponens on premise 1 and our recently get answer, which is P, and do a modus ponens that will be resulting in Q. So in conclusion, he buys a car. In summary, logical connectives such as and, or, not, and implies are used to form complex logical statements. Truth tables help determine the truth value of these statements. A tautology is always true, a contradiction is always false, and a contingency can be either true or false. Logical implications describe a relationship where one statement follows from another. If P, then Q. Rules of inference like modus ponens and modus tollens allow us to derive conclusions from given premises, helping us to validate arguments and ensure logical consistency.